All right, so my warm-up here, we're doing domain and range. Domain is all the x's. Okay, which way do x's go, guys? Sideways. So does this thing go to the left, to the right, or both? Both. So if it goes both ways, you're going to tell me the domain is what? All real numbers. Okay, range. Which direction do ranges go? Up and down. Does this thing go up, down, or both? It only goes down on the sides, doesn't it? Okay, which means everything's going to keep getting lower if it's going down. Agreed? What symbol do I use for lower? Less than or equal to. What is the very highest this thing will go? 2. Fantastic. Any questions there? Okay. Number 2. Does this thing go to the left, to the right, or both? Only to the right. If my x's go to the right, are they getting bigger or smaller? Bigger to the right for the x's. So that means the x's are greater than or equal to. What is the very lowest the x will go? The x's are here, right? The very lowest the x's will go. Okay, so 5 is right here, isn't it, on the x? The x's go right here at this 1 is where the last x is. Does that make sense? Yeah? Okay, how about the range? Does this thing go up, down, or both? This one here is going to go down, right? That one's going to go up. So if it goes both, what are you going to tell me for the range? Okay. Does this thing go to the left, to the right, or both? Both, so my domain is range. Does this thing go up, down, or both? Goes up. So if my ranges are going up, does that mean greater than or less than? If they're going up, that's greater than, right? And what was the very lowest the y's would go? -4. Now I hope we're not going to say -1 here, because -1 is the x there, right? Range talks about the y's. Any questions on those? Warm up is good? We sure? Okay, so same fill in the blanks that we had yesterday. Let's see how much you remember. In order to solve an equation, you must blank the variable. Isolate the variable. But in a quadratic equation, there could be 2 different types of variables. Ladies and gentlemen, if I have 2 different types of variables, can I isolate? So for example, something like this. Can I isolate? No, because there's 2 different of them, right? So if I can't isolate it, then what do I have to do? You have to factor it. Set it equal to 0 and factor it. Okay, but yesterday, instead of factoring, we graphed, right? That was another way to do it. Okay, solutions to quadratic equations can be called many different things. A 0, because they have to be equal to 0, right, before I even graph them. They could be called roots. And where are they found on a graph? The x-intercept. Now, folks, I want to stress to you that this is only true for quadratic equations. What does quadratic mean? Gotta speak up. What does quadratic mean? What does the equation have to have in it if it's quadratic? A squared. The highest power has to be 2. So if I have something like this, we're not on our Chromebooks here yet, folks. If I have something like that, that is quadratic, correct? Shane, can you please put that apple on top of those papers over there? That glass apple. Okay, so this is a highest power of 2, right? Which means it's quadratic, which means I can use all this, right? What about something like this? No. So you have to make sure, I'm up here, have to make sure that it's a quadratic equation that you're actually dealing with. Otherwise, none of this makes any sense. Okay? All right, so what are we doing next here? Some word problems for you. It says, find 2 numbers that have a sum of 17 and a product of 60. Sum of 17 and a product of 60. Okay, first and foremost, what does the word sum mean? Add, right? And what does the word product mean? Multiply, right? Okay, so can you write me an equation that shows the sum would have to be 17? Don't give me numbers, I just want an equation. Do I know what the two numbers are? There we go. X plus y is going to be equal to 17. Can you give me an equation that says their product would be 60? X times y equals 17. Now, folks, that's two equations, isn't it? Remember, we talked before Christmas, actually after Christmas. If you have two equations that we're trying to solve simultaneously, it's called a system of equations, right? In order to solve a system, we had three methods. You could either eliminate, you guys remember doing the opposites and eliminating? We could substitute, or we could graph, right? What do you think we're probably going to do? We're probably going to do what? What have we been using? Desmos, right? So we're probably going to graph these. Fair? If I want to graph them, what do I have to do to them first? Okay, I either need to set them equal to 0, or I got to get them equal to, I got to be y equals, right? Okay, let's go ahead and get the y's by themselves. How do I do that? I got to minus the x. If I subtract this x on both sides, I get y equals negative x plus 17. So now that one's ready to go, right? Okay, how do I isolate the y in that one? Divide by x. If you divide by x, I get y equals 60 over x. And now they're ready to graph. So why don't you go ahead and get those on your graph, please. Y equals negative x plus 17 and y equals 60 over x. How we doing, folks? Does everybody's graph look like mine? Notice if I zoom out here, we've got this other blue line over here. There's actually two lines for the blue part, okay? But I'm going to zoom in because this is what I'm going to want. Now, think back to when we solved systems. If you were looking at a graph with your lines on it, how did you know where the answer was? Okay, that is if we're talking about quadratic equations, correct? Hold on a second. Quadratic means they have power of 2, correct? Do these have powers of 2? Okay, so where are the answers here? Where they cross. Now, folks, they cross at 2 points, don't they? Okay, so I'm going to have two answers for this. Everybody see them? 5, 12, and 12, 5. Okay, well, what would you tell me the two numbers are then? 12 and 5. Could you say 5 and 12? Yeah, it doesn't matter the order in which you write them. My answers here are 5 and 12. Because what happens when you add 5 and 12? You get 17. What happens when you multiply 5 and 12? See how that works? Okay. Ready for the next one? Find two numbers that have a sum of 10. What you going to tell me? But in order to graph them, I got to get the y by itself. If you subtract the x, what's the new equation? And how about the other one? Divide by what? Perfect. which gives you what? How we doing, guys? Fine? Okay, put them in. So where are the answers on my graph? Where they cross, and how many times do they cross? Twice. Now, hold on a second. In my last problem, the 2 points were the same numbers, just in different order, right? Is that the same case here? Are they the same numbers, just in a different order? Yes. So what are you going to tell me my answers are? Could you say -4 and 14? Yes. Because what happens when you add 14 and -4? And what happens when you multiply 14 and -4? Bingo. Doing good, guys. You know something is wrong. Yep. You'd have to go back and look at what you did. You could. I mean, these are just going to be nice for you because it's just, yeah. Okay, find two numbers that have a sum of -5 and a product of -36. Solve the first one. What will you do? Okay. Okay. Too fast, too slow, just right here, folks. Just right? Okay. Bless you. Everybody doing all right? Did the same thing happen? Same numbers, just switched. Okay, so what are my answers here? What was it again? What happens when you add them? And when you multiply them? What can I do for you? Yep, absolutely. Just move your everything back to where the plug is. Okay, questions on the front, folks. Okay, let's move it over to the back. Okay, more practice on these word problems here. A goalie kicks a ball upward with a velocity of 65 feet per second, and her foot meets the ball 1 foot off the ground. The quadratic function that represents this is h equals -16t squared plus 65t plus 1, where h is the height of the ball after t seconds. Everybody understand the situation? Yes? Okay, so what are you doing right now? Go for it. No, just leave it in there for now. How's your graph look, folks? Same as mine? Doing okay? Yeah? Okay, so what is the maximum height of the ball? Where does that happen? The very top. What is that very top point called? The vertex. So how high will this ball go? 0.016, right? Feet. Does everybody see where that's coming from? Chase, how you doing back there? Okay? Okay. So 67.016 feet. How long is the ball in the air? Meaning, how long before it comes back down, right? Okay, hold on. Let me ask a question first. Where does that happen? When it hits the ground, and this line right here is like my ground, right? Okay, go ahead, William. How long does it take? 7, 8 seconds. Okay. Approximately how high is the ball after 1 second? Now, there's 2 ways to do this. I want you to tell me both ways that we could do this. Plug what in? Plug in 1 for which variable? The t. So you can either take this up here and put that 1 right where the t's are, or what else could you do? I'm probably going to have to zoom way in and figure out where 1 is, right? Oh boy, it's way up there. I think it probably would be easier to just plug it in. So let's do that. What'd you get? 150? Did you do this, Greg? You just followed the line? Can you grab your guys' calculators and do this and see if we get what Greg got? You can do it right on your computer. 50? I thought he told me 150. 50? 50? Oh, you mean 1 comma 50. I gotcha. 50 what? Feet. Okay. After how long is the ball 60 feet high? Okay, now where's the 60 going to go? Is 60 a time or a height? It's a height, which means that needs to go in for what variable? The h. So what does that look like? Everybody good here? But you should know, if I want to graph this, it's got to be equal to 0, doesn't it? So I'm going to move this 60 over. 0 equals negative 16t squared plus 65t minus 59. So folks, you're going to have to go into Desmos, and you're going to have to change the equation you just put in. Everybody all right with that? Yes? That negative 59 is now on the end. We all see it? Are we sure? Yes. Where do the answers happen? On Desmos. Where on Desmos? Okay, this is a quadratic equation, correct? Because it had a power of 2. So solutions happen where on the graph? The x-axis. They are the x-intercepts, the zeros, the roots. So, what are my answers? Round to the nearest tenth, please. Okay. 1.4 seconds. And you said 2.7? Why are there 2 answers? Yeah, think about it. If I'm kicking a ball, it's going to go like this, right? They want it to be 60 feet high. You could reach 60 foot high there and 60 foot high there. It's going on the way up for 1 point and on the way down for another point. How we doing, guys? You sure? Okay, this letter D is different than what we've done in the past. That's the new stuff there, okay? All right, moving on. This time we're building a model rocket for a science project. The equation is right there. That models the flight of the rocket launched from ground level at a velocity of 250 feet per second, where h of t is the height of the rocket in feet after t seconds. How high will the rocket fly? So what are you guys doing? Okay. Well, it's a rocket, right? There it is, right? Okay. So tell me, where am I looking to figure out how high it will go? The vertex, which is right up here. So tell me, how high will it go? How far will it go? 900 and what? 0.563? 976 point, say it again, William. And this is in feet. Still doing all right back there, Chase? Okay. How long is the rocket in the air? Well, that means it's got to hit the ground if it's going to not be in the air, right? So that's one of these points, correct? 15.625 seconds. Okay. How high is the rocket after 15 seconds? Now, I hope that because that graph was so tall, you would agree with me that I'm not going to look at the graph. What am I going to do with this 15? For T or for H? It's a time, so it goes in for T. Let me get it plugged in here real quick, Ray. What are you telling me it is? 150 what? Okay. Is everybody following okay? Yeah? After how long is the rocket 20 feet high? 120 feet high, excuse me. Where is that going? That's a height, isn't it? So that's going to go for the h. So it'll be 120 equals negative 16 t squared plus 250 t. If I want to graph this to find the answer, what do I need to do? Move the 120 over. So now I have 0 equals negative 16 t squared plus 250 t minus 120. That's the equation I need to solve. So what are we going to do with it? Put it in Desmos. Now remember, folks, if you really felt good, you could factor this thing, right? I don't think we want to factor this. You can, and it will work, but it's going to take you a lot of work. Somebody read that off to me. Negative 16 t squared plus 250x. And then minus 120. How's it look, folks? Where do my answers happen? At the x-axis, correct? So, how long will it take it to get 120 feet high? 0.5 seconds and 15.1 seconds. Still doing all right? You sure? Good. I would like you to do the next rocket problem on your own, please. Okay, most of you seem to be doing pretty well here. How high will the rocket fly? That happens at the vertex. 284 point what? Feet. And you could have just rounded that to 0.8. The directions would have to tell you what you wanted to round to, okay, folks? Good. How long is the rocket in the air? Meaning, how long does it take to come back down? Okay, 8.4 what? And 8 after that? Okay. Again, I didn't really specify what to round to, so that's on me, not on you. How high is the rocket after 6 seconds? Good. So hopefully you just took that 6 and you plugged it in right there. Good. After how long is the rocket 260 feet high? Where did that 260 go then? For the y this time. Which means you probably had to then move that 260 over, right? which means you would have had that. And then your answers happen where it crosses the x-axis, 3 seconds and 5.5 seconds. Fantastic. Any questions for me, folks? It's word problems. It's finding vertex and axis of symmetry and y-intercepts and maxes and mins and that kind of stuff. Well, you tell me, where's a vertex? If I show you this, and there's my graph, if this is the x and this is the y, where's the vertex? That's the x-intercept. The vertex is right there. Correct. Yes, we're going to have to go back and look at that, okay? Actually, we are going to review in class tomorrow, and then your quiz is going to be a take-home quiz, which means it will be due on Monday. Does that make sense to you? Yes? I don't know off the top of my head. But that means you will have to bring it back to me on Monday, right? And if you don't, it's a 0. And I will not be taking it late because you have all weekend to do it. Good? And it's a take-home quiz, absolutely. Okay, so I'll write your homework up here.